All right, this is Honors Algebra 2 Pre-Calculus. We're doing 6.4 in Algebra 2, which is properties of logarithmic functions. So recall in Chapter 2 that we learned a bunch of properties for exponents, and it was impossible to work with exponential expressions without memorizing those rules, right? So here's a review of the properties of exponents from Chapter 2. You're welcome to go through them if you need to, but remember that if we're multiplying two exponentials with the same base, we add the exponents. If we're dividing two exponentials with the same base, we subtract the exponents, top minus bottom. If we have a power on a power, we multiply the powers. Power of a product, we can distribute that power to the different terms of the product, and a power of a quotient, we can distribute that power to the different terms inside the quotient. So those rules are important. We're going to sort of learn a reverse set of similar rules for logarithms. And again, just like we saw in Chapter 2, if you don't know how to do these properties, you're going to find yourself sort of at a dead end with a lot of problems. So it is important that we learn how to use them. All right, so properties of logarithms. These are new material for Chapter 6. So these are for positive numbers m, n, and b. So see, the m, n, and b are all positive numbers. Okay, so they're positive numbers. And it's important that b not be 1. So the base of a log is not 1. So if you have the log base b of m times n, it can be split into two logarithms, the log base b of m plus the log base b of n. So sort of the corresponding similar rule in exponentials was that if we had e to the m times e to the n, it became addition, right? E to the m plus n, right? So in exponentials, two exponentials as multiplication became one as addition. Well, here it's the reverse order, right? So one way you can kind of bail yourself out if you get a little bit confused, right? So sort of the reverse of this is that two logs with multiplication on the inside becomes, or sorry, one log with multiplication on the inside becomes two logs of addition, sort of the opposite of this property. And we can see the same thing with the exponentials. If you are dividing two things inside a logarithm, you can split it up into two logarithms with subtraction. Well, we saw that here with e to the m over e to the n, right? That was two exponentials. When it became one exponential, it was with subtraction. Well, the reverse is true here, right? It was two logarithms with subtraction. It's one with division, right? So they're sort of related. It's good to keep in mind that division and subtraction is sort of related. There is no really corresponding rule here. So the log base b of m to a power, you can drop the power down in front. So you can take this power and drop the number down in front, right? And make it p times the log base b of m. So I would say plog, but you get the idea. So again, these are sort of related. Just to show you a quick example of what this would look like, and then we're going to do a bunch of examples. If I gave you the log base b of, let's say, 2x, you could change it to the log base b of 2 plus the log base b of x. If I gave you the log base 2 of 5/3, you could change that to the log base 2 of 5 minus the log base 2 of 3. You could split it apart. If I gave you the log base 2 of 5 to the 7th, you could drop the 7 down in front and make it 7 times the log base 2 of 5, okay? And then the last thing, and we've seen this, a similar one-to-one property, okay? So this is a one-to-one property. If log base b of x is the same as log base b of y, you can conclude that x and y must be the same. So this is a one-to-one property. So remember as a kid when you were learning to tie your shoes and you had to tie and untie and tie and untie and tie and untie and so on, right? In the next few examples, we're going to basically be doing something akin to that. You need to learn to apply these log properties. Later in your math career, and also, honestly in this chapter, but also later in your career with me and also past high school, you'll need to apply skills without being expressly asked to do so, right? Nobody's going to say expand the logarithm or condense the logarithm, but it will be a necessary step to do other things in the aims to reach a larger goal, right? So for instance, if you're solving an equation in Algebra 2 or integrating an expression in calculus, sometimes you have to do these things even though I don't expressly ask you to do them. So what we're about to do in the next couple examples is just practice this skill of combining all these logs into one log or separating all of them as far out as we can, which is called expanding them. And that's going to seem a little bit crazy that I make you do something and then undo it and do something and undo it, but it's the same idea as that analogy of tying your shoe. You have to learn how to use the skill because later I'm not going to ask you to use the skill. I'm just going to ask you to do some other problem, and one small step of doing that problem will be that you need to know how to expand or condense a logarithm. All right, so condense the logarithmic expressions into a single logarithm. So two logs being subtracted, right, can be rewritten as one log with division. So log base 3 of 45 over 9. Now I could stop there, but because 45 over 9 is a nice happy number, you should go ahead and get that it's a 5. Okay, so log base 3 of 5. That's it. That's what you want to do. When I combine multiple logs, see how they're all base 2 here, right? I'm going to combine all these logs. Anybody with a plus sign in front ends up on the top. So see how this has a plus that's implied. So these two are going to go on the top. That's going to be multiplication. Anybody with the minus, because of this minus sign right here, is going to go in the denominator. So what's going to happen is I'm going to get that this is the log base 2 of a 5 times an x divided by a 10. And that answer is not wrong, but because 5 and 10 have a number in common, you would cancel them, and you're going to get the log base 2 of x over 2. And that's the best I can do. For C, I'm going to need to move these powers up before I can do anything else. So I'm going to start by moving the powers up, and I'm going to get that this is the log base 2 of m to the 5th minus the log base 2 of n to the 2nd. Then I'm going to notice that the subtraction means I'm combining them in division. So this is the log base 2 of an m to the 5th on top of an n to the 2nd. Sorry, I accidentally almost made it a subscript, and I didn't mean to. There you go. I apologize in advance that sometimes my handwriting is pretty bad. All right, so last one. I'm going to move all of these powers up. So I'm going to get that this is the log base b of an m to the 4th plus a log base b of an n to the 1/2 minus a log base b of this whole quantity 2p to the 3rd, which is going to matter because the whole 2p is to the 3rd, okay? When I clean this up a little bit, the only thing I'm going to do really to clean this up is make this an 8 and a p cubed. So I'm going to go ahead and recognize that that's the same as an 8 and a p cubed. So now I have that this is the log base b, so I'm just going to put an arrow there. Anybody with a plus goes on the top, so these two have plus signs in the front, right? So they're going to go on the top. So I'm going to get an m to the 4th, n to the 1/2. And in the denominator, I'm either going to leave it as a 2p quantity cubed or make it an 8p cubed, right? Either of those are fine. You could leave it as the whole thing in parentheses 2p quantity cubed. That answer is fine. The other way you might see it is with the 1/2 exponent being written as a square root, because that's what 1/2 exponent is. So you might see it like this, right? And it would be totally acceptable for the denominator to be 2p in parentheses the whole quantity cubed. Either of those, any of those would be fine. So any of this would be fine. Okay, that's basically the gist of it. Now, there's always somebody, and let's just do a quick little side note for a sec, right? There's always somebody who says, okay, but what if I pulled the negative up with the 2p? So let's do another fake example really quickly. Okay, what if I gave you the log, that's not how you spell log. Come on, brain. What if I gave you the log, let's say log base 2 of a plus log base 2 of b minus 5 log base 2 of c. Okay, so the trick here is that I only yank up the 5. So this is the way that I've been doing it. I only put the 5 up there, right? So I would end up with the log base 2 of an a and a b on top and a c to the 5th on bottom, because I'd yank the 5 up and say, oh cool, that's gonna look like this, right? And actually I can add a step if that makes it a little bit easier. Let's just, so one option, right, is to say that this is the log base 2 of a plus the log base 2 of b minus the log base 2 of c to the 5th. And then when I put them together, I get log base 2 of a and b on the top and c to the 5th on the bottom. Great. The other option is, let's say you did pull the whole negative 5 up. If you pulled the whole negative 5 up, you would get that this is the log base 2 of a plus the log base 2 of b plus the log base 2 of c to the negative 5th. Well, when you put them all together, because they're all plus signs, they're going to be multiplication, right? It'll be a times b times a c to the negative 5th. But then we know where a c to the negative 5th lives in this fraction. It lives on the bottom, and you'll see I land at the same spot, right? So if you didn't ignore that negative sign when pulling the number up, so you could treat this entire thing as a negative 5 when you pull it up, but if you do that, you're going to get a plus here, and I find that that's a common mistake people make. I would suggest that you only pull the number up as an exponent, and you leave the negative sign there. All right, go ahead and give P1 a try, right? I'm going to walk through it after you, so pause me, and then I'm going to go ahead and walk through it. So this is a log base 4 of 16, right? And actually, we can simplify this further, so that's not wrong, but we're going to learn how we can actually simplify this, and this is actually a 2. It's 2, because 4 to the 2nd would give me 16, right? 4 to the 2nd gives me 16. But technically, I have combined it into a single logarithm with log base 4 of 16. For this one, right, these are going to go on the top. This guy with the minus is going to go on the bottom, so I'm going to get that this is the log base 3 of a 4x on top of a 2, which means I'm going to cancel one of those 2's and get the log base 3 of 2x. All right. This is going to be a 7 that comes up and a 4 that comes up. So I'm going to get that this is the log base 3 of y to the 7th minus the log base 3 of x to the 4th. So when I put it together as division, I get the log base 3 of a y to the 7th over an x to the 4th. All right. And then for the last one, this is the one that's a bit complicated, right? I'm going to bring these exponents up. Give myself a little bit more room, maybe. So I'm going to get that this is the log base b of a 3c all to the 1/2, which I need to keep in parentheses, plus a log base b of a 4d all to the 1/2, minus a log base b of a 5e whole quantity squared, right? So these are going to end up on the top. So I'm going to end up with a log base b of, you can either leave this as a 3c to the 1/2 times a 4d to the 1/2, all over a quantity 5e to the 2nd. That's fine. Or you could recognize that these are actually square roots, right? So this is the same as the log base b of root 3c times root 4d all over 5. You could do a 25e squared if you want. You could distribute, right? This is fine, right? Both of these answers are fine. You could go farther, right? You could go farther because of the 4. So you could make this a log base b of the square root of a 12 CD all over this 25e squared. That's also right. You could yank a 4 out of that because this is a 4 times a 3. So you could also make it this 2 root 3 CD all over 25e squared. All of those are right, right? So remember, it's my job to spot if your answer is right, so don't panic. In general, I don't give you a ton of these questions as open-ended questions on an exam because it can be frustrating that there are 30 different right answers. I mean, really, every little thing that you do here is just tweaking an acceptable answer. So, all right. Now we're going to do the reverse. Fully expand the logarithmic expression. So basically the opposite of what I asked you to do in E1, right? Tie your shoe, untie your shoe, tie your shoe, untie your shoe. You dig? All right, so this is 1 log with multiplication. So when I split it into 2 logs, it's going to be addition. And that's it. Now, it might seem silly that I'm asking you to do this, but you'll survive. So again, the goal is that I need you to learn how to use these properties, right? So this is the same as an x to the 2nd times a y to the 1/3. When I split it up, that's going to be a log base 5 of an x to the 2nd plus a log base 5 of a y to the 1/3. And then I can drop both of those exponents down, right? So I'm going to end up getting a 2 log base 5 of x plus a 1/3 log base 5 of y. One thing to note here, and I think it's probably been pretty obvious in these examples, all the logs have to be the same base. So if you go back to these, all of these are base 3, all of these are base 4, all of these are base 3. The rules only work if the logs have the same base. All right, so now in this one, the z is in the denominator, so when I split them up, the z will get a minus in front and everybody else will get a plus. And if you're doing this in your head and you're thinking, Hogan, I can totally do all of these things at once in my head, I can drop the exponent down at the same time, that's fine, right? I'm okay with it. If you're doing it on a test, you should show a little bit of work. But if you're able to jump in your head to 7 log base 8 of x plus 4 log base 8 of y minus 3 log base 8 of z, nobody thinks you're cheating, right? But be mindful that if you don't show any steps, those are 8s by the way, they just don't really look like it, but they're 8s. If you don't show any steps and something goes wrong, then there's not much I can do to help you, giving you credit or anything else. All right, go ahead and try P2. You're welcome to pause me if you want. This is going to be the log base 2 of x minus the log base 2 of 13. This one, if you want to just write that this is a y to the 1/2 above it, you can. This is going to be a log base 7 of x to the 5th plus a log base 7 of y to the 1/2. I drop the exponents down in front to get my final answer of 5 log base 7 of x plus 1/2 log base 7 of y, right? So that was my answer. That's my answer. For this one, both of these end up on the bottom. So I'm going to get that this is the log base 4 of x cubed minus the log base 4 of y to the 5th minus, so see how they're both negative, right, because they're both on the bottom, log base 4 of z to the 8th. And then I drop all the powers down to front. Again, if you can do all of this in your head and you think, hey, Hogan, why do I have to show you that middle step? That's fine. Most of the time it's not going to matter at all. I don't need you to do work just to do work. But remember, at some point in your math career, you're going to need to show some work because things can start to go wrong when problems get more difficult. All right, so let's relate exponential and logarithmic properties. So Because exponents and logs are inverses, right? So remember that by being inverses, they essentially undo each other, right? So they undo one another. That's what inverses do. So log base b with a b to the x on the inside. So what this means, this doesn't mean multiplication. It means log base b, and then inside the log is a b to the x. They cancel and just give you x. Similarly, a b raised to the log base b of x. Again, that's not multiplication. This is an exponent, right? They cancel and they just give you an x, all right? There are two other special cases that are worth knowing. The log base b of 1 is 0. So that's worth mentioning. Anytime you have a 1 inside a log, and the reason is b to the 0 would give you 1, right? Whatever the base is, because your base is a positive number that's not 1, base to the 0 gives you 1. And then log base b of b is 1, and that makes logical sense too, because b to the first power would just give you b, okay? All right, cool. So let's do an E3 and a P3. We're going to evaluate without a calculator. So we're going to be using these two properties to evaluate without a calculator. Right now, you actually don't know a whole lot about how to put these in your calculator anyway, but we'll talk about that in a little bit. So I noticed that this is a log base 6. There's nothing I can do to change that 6. But what I could do is rewrite 136 as a power of 6, right? So that is a power of the base of the log. So I can recognize that this is the log base 6 of a 6 to the negative second. Those cancel, and I just get a negative 2. The other way to think about it, if you don't like the canceling idea, is to say, oh, that's a negative 2 in front of a log base 6 of 6. We've already established that log base something of itself is a 1, so that's a negative 2 times 1, which is a negative 2. 8 raised to the log base 8 of 2 is just a 2. For this one, I need to rewrite 32 as a power of 2, right? So I'm going to recognize that this is the log base 2 of a 2 to the 5th, meaning these cancel, and I just get a 5. And then this 3 raised to the log base 3 of 4, these cancel, and I get a 4, so I get 5 plus 4, which is 9. All right, last problem, and then we'll stop for this video. Go ahead and give this a try. You are welcome to pause me if you want. So this is the log base 8 of 64 is 8 squared. Well, that's convenient. It's a 2, right? 7 raised to the log base 7 of 4 is just a 4. They cancel and give you this thing on the inside. I'm going to rewrite this as a 5 to the negative second. So I get the log base 5 of a 5 to the negative second. Those are going to cancel. Plus a 12 raised to the log base 12 of 5. Those cancel. I get negative 2 plus 5, which is a 3. All right, and that is it for this video.